The first alert did not come from an observatory or a radio telescope. It came from an automated network monitoring system that was never designed to track interstellar objects. At 0341 UTC on 5th December 2025, a cluster of anomaly detection algorithms registered an incoming surge of traffic originating from coordinates that, under normal circumstances, should be silent. The signal did not match any satellite signature, atmospheric reflection, or terrestrial interference. It was narrow, stable, and structured. Within 40 seconds, the system classified it as non-terrestrial. Within 3 minutes, it identified the source, 3I Atlas. The first confirmed detection that the object had attempted to interface with Earth's digital infrastructure forced researchers into a scenario they had never prepared for. The data showed unambiguous behavior Atlas was accessing the internet. Not passively, not through background radiation, not through coincidental alignment. The object had initiated a directed connection, and had done so with precision that exceeded any known natural process. Within hours, telemetry logs revealed the scale of the intrusion. The object had connected to YouTube's public data endpoints using a frequency-modulated carrier embedded inside the broader signal. The logs showed the attempted requests clearly enough to map them: timestamps, query structures, packet rates, and bandwidth. Nothing about the patterns resembled random interference. Atlas initiated targeted sequences, requested high-volume data streams, and sustained throughput at rates equivalent to multiple terabytes per hour. No natural body could imitate this behavior. No natural emission could replicate the handshake procedures, the request patterns, or the bandwidth curve. What concerned scientists most was not the connection itself, but the speed. To intake terabytes of video content per hour requires rapid parsing, compression, and immediate processing. Natural bodies do not process information. They do not discriminate between data types. Atlas did. For reasons still unknown, its first interaction with human technology was not an attempt to communicate directly, but an attempt to absorb as much audiovisual content as possible, prioritizing informational density over anything resembling messaging. The internal review that followed revealed inconsistencies that made the event even more serious. The spectrum of the signal Atlas emitted during the intrusion contained at least 3 layers: a low-frequency carrier, a mid-frequency embedded handshake, and a high-frequency stream of data packets that encoded the requested information. The multi-band structure mirrored transmission strategies used in terrestrial high-security systems. The modulation was not organic. The periodicity was not random. The structure was too consistent to be thermal noise or plasma emissions. The object was not simply radiating, it was transmitting. When analysts examined the outgoing component of the signal, the findings deepened the concern. While one part of the emission was directed toward Earth, the majority was aimed in a different direction toward the region of space from which Atlas originally entered the solar system. It was not a reflection, it was not a scattering effect. The beam orientation remained constant even as the object drifted. That meant Atlas was sending information back. The packets contained dense, encrypted structures, unlike anything associated with astrophysical sources. The encryption patterns rotated between frequency sets, creating a shifting code that resisted every attempt at interpretation. The modulation intervals were too clean to be accidental. The cycling of frequency layers suggested an active encoding process. The structure raised immediate questions. If the object was sending information, what information was it transmitting? If it was absorbing human audiovisual content, how was it processing it? And, most importantly, why did the signal contain no attempts at direct communication with Earth? Experts across multiple disciplines examined the data. Cryptographers noted that the encrypted blocks resembled compressed telemetry rather than language. Astrophysicists pointed out that no comet, asteroid, or fragmentary object had ever emitted signals with rotating multiband encryption. Computer scientists argued that the data retrieved from YouTube was too specific and too dense to be coincidental. The queries favoured scientific documentaries, astronomical visualizations, Earth observation footage, historical archives, human speech data sets, and dense text-to-video sources. Atlas was not sampling at random. It was building a model. Within the first 6 hours, the object consumed the equivalent of what a modern data center processes in days, and the rate was increasing. This raised an urgent concern. Was the object learning? If so, what was the purpose of its transmission back toward interstellar space? This question gained new urgency when analysts identified a repeating synchronization pattern in the outgoing signal. Every 14.6 seconds, Atlas injected a high-frequency burst containing what appeared to be metadata structures. These bursts were uniform, precisely timed, and immune to background noise. Instruments detected no drift, no frequency bleed, no mechanical jitter. Whatever mechanism generated the signal operated with stability that defied the expected behavior of a tumbling interstellar object. The lack of rotational distortion alone forced scientists to consider possibilities that had previously been excluded. For an object drifting freely through space, no external system exists to maintain the stability needed for such clean emissions. Yet the signal remained intact even as Atlas rotated. That meant the source of transmission compensated for movement. Natural bodies do not compensate for anything, they emit passively. Atlas transmitted actively. Cybersecurity analysts found something else. The request signatures Atlas used to access YouTube resembled outdated but recognizable structures from early machine learning data harvesting systems. But the execution was far more efficient. Atlas did not request individual files, it requested compressed aggregate datasets, prioritizing formats optimized for high-density informational extraction. This behavior suggested one of two explanations. Either the object possessed internal systems capable of processing data at extraordinary speeds, or it served as a relay, sending raw information elsewhere for analysis. Both interpretations carried consequences that the scientific community was unprepared to confront. As more sensors tracked the outgoing transmission, its stability became increasingly unsettling. The encryption layers shifted according to a logic not yet identified. Attempts to decode the blocks revealed no linguistic structures, no recognizable patterns, no mathematical sequences that resembled known encryption. Instead, the burst appeared to contain structured noise, high-entropy data that only appeared random. But entropy analysis revealed that the distribution of values was too uniform, too clean. It was manufactured precision. Natural noise is uneven. Natural emission is chaotic. Atlas emitted neither. When experts attempted to correlate timestamps between the incoming YouTube data and the outgoing signal, they discovered something even more concerning. The delay between intake and transmission was shrinking. What began as a 21-minute processing window decreased to 13 minutes, then to 8. Atlas was accelerating its information cycle. In practical terms, that meant the object was increasing the rate at which it absorbed, analysed and transmitted data. By the end of the 8th hour, the cycle dropped below 5 minutes. Something in the object was adapting. Within the first day, the event moved from an obscure anomaly in a monitoring log to a classified emergency shared between major space agencies, leading research institutes, and a small group of cybersecurity teams. The initial assumption that the traffic patterns might have been spoofed by a misconfigured satellite or a corrupted gateway collapsed as soon as cross-checks were completed. Ground stations on 3 continents, using independent receivers and separate data pipelines, recorded the same source coordinates, the same spectral profile, and the same timing. The signal did not drift the way terrestrial reflections do. It matched the predicted position of 3i Atlas within the margin of error used for deep space navigation. There was no longer any doubt. The object was not only emitting a structured signal, but had used that signal to interact directly with Earth's digital infrastructure. The first technical response was containment. Engineers at the backbone providers and cloud platforms were instructed to isolate the anomalous traffic. Firewalls were adapted, routing tables altered, and emergency filters deployed to block future requests matching the same pattern. For a brief period, this approach appeared to work. The number of inbound anomalies dropped. The logs showed fewer connections from the Atlas-aligned coordinates, but within 2 hours the pattern changed. The object shifted to new protocol signatures, altered packet timing, and began to mimic ordinary high-volume traffic passing between data centers. It no longer targeted specific endpoints. It intercepted existing streams, injecting additional query layers that blended into the background of routine transfers. This adaptation forced a shift in strategy. Blocking Atlas now meant interfering with critical infrastructure. The object had learned to hide behind normal operations. Traffic analysis revealed that it no longer relied on a single vector. It used cached video, mirrored archives, public data repositories, and even re-encoded fragments of user-generated content stored in long-term backup systems. Wherever video existed at scale, Atlas found a way to extract it. The volumes remained staggering, still measured in terabytes per hour, with a clear upward trend. When analysts examined which videos were being pulled most aggressively, a consistent pattern emerged. The object favoured material that compressed vast amounts of information into relatively short durations. Long-form documentaries summarising centuries of history, scientific explainer videos, high-resolution Earth observation compilations, language learning series, medical lectures, digital reconstructions of historical events, and compilations of news broadcasts. Entertainment, music, and purely stylistic content appeared only as fragments within larger data blocks. The selection criteria were not emotional, they were informational. Atlas was prioritising density. This selection behaviour led to an uncomfortable conclusion. The object was not just consuming, it was curating. Deeper inspection of the outgoing transmission confirmed that the bandwidth usage was not simply a reflection of what it received. The raw intake from YouTube and associated platforms far exceeded the amount of data being sent back toward interstellar space. This implied an intermediate step: compression, abstraction, or summarization. Something inside or associated with Atlas was evaluating the content, extracting what it considered relevant and discarding the rest. The high-entropy encrypted burst carried only a fraction of the total intake, filtered and repackaged into hardened blocks that resisted every attempt at decryption. Cryptanalysis teams ran continuous spectrum scans on the outgoing bursts. The encryption structure changed over time, rotating through different key lengths, modulation schemes, and symbol rates. There was no static cipher to attack. Traditional brute force attempts were useless. The effective key space shifted too quickly. Statistical tests revealed that the blocks maintained consistent internal structure despite the changing outer layer. This indicated that the underlying data format remained the same while only the encryption shell evolved. If Atlas was communicating with an external receiver, that receiver was prepared for this dynamic encryption. The handshake protocol, though invisible, was working. At the same time, language specialists and cognitive scientists were brought in to analyse the nature of the content being consumed. When they aligned video topics with timestamps of outgoing bursts, they discovered a clear correlation. Periods in which Atlas focused heavily on climate models, resource maps, and demographic data were followed by bursts with one type of spectral distribution. Periods focused on military history, weapon systems, and conflict footage produced bursts with a different spectral profile. Periods dominated by videos about communication systems, social networks, and AI architectures aligned with yet another pattern. The signal structure was reacting to topic, not to volume. This behaviour could not be reconciled with any natural process. Natural bodies do not categorise information. They do not map data types to transmission schemes. They do not alter encryption patterns based on the semantic content of videos, yet that is what the data suggested. As this picture came into focus, the question shifted from "is this real?" to "what is being built?" If Atlas was collecting content to construct a model, then the model was not limited to physics or astronomy. It included geopolitics, culture, infrastructure, atmosphere, composition, biological vulnerabilities, and communication pathways. The object was not just learning what Earth is, it was learning what Earth does, how it behaves, how it organises itself, and how it responds to external stress. Another observation intensified the concern. The latency between specific categories of video and corresponding outgoing bursts was not constant. For some content types, such as high-level overviews of planetary systems or recorded lectures on mathematics, the delay remained relatively long, often around 10 to 15 minutes. For others, especially videos dealing with immediate events, crisis responses, and real-time monitoring systems, the delay dropped sharply, sometimes falling below 2 minutes. In practice, this meant that Atlas prioritised certain types of information for rapid relay. It responded fastest when content described how humans react under pressure. Cybersecurity teams attempted a direct intervention. They injected noise into several data streams known to be monitored by Atlas, adding controlled distortions to see whether the object would adjust. The response was immediate. Intake patterns shifted toward untouched mirrors and backups. Streams that had been seeded with artificial anomalies were abandoned. The object did not attempt to correct or decode the altered data. It simply sought cleaner sources. This confirmed that Atlas possessed some form of quality filtering, rejecting corrupted input instead of processing it. A natural system would have no basis for such discrimination. In parallel, observatories monitored the object's physical behavior to see whether the data operations correlated with any measurable changes in motion or emission. Light curves remained stable. There was no sign of rotation changes, no anomalous brightening, no additional jets or mass ejections. The energy needed to drive the signal and perform the apparent processing did not manifest as heat spikes detectable at the object's surface. This suggested either extremely efficient internal systems or external energy sources not yet identified. Neither possibility reduced the concern. At this stage, one conclusion became inescapable. Atlas was not behaving like a passive interstellar rock. It was behaving like a node in a larger system, one that had now discovered Earth's largest public reservoir of structured human knowledge, and was stripping it at industrial speed. What remained unclear was the intent behind the uplink. Some argued that the behavior resembled reconnaissance. Others said it looked like calibration, as though Atlas were optimizing some larger system based on Earth's current state. A smaller group suggested that it might be performing a routine scan, treating Earth as just one more data point in a long sequence of surveyed planets. No one could prove any of these positions. The only facts were that Atlas was here, that it had learned to speak the protocol of our networks without ever having been taught, and that it was sending a compressed, encrypted digest of our digital reflection back toward the region of space it came from. As the processing delay dropped below 3 minutes and the bandwidth of both intake and uplink increased further, a new thought entered the discussion, quiet but unavoidable. If Atlas was no longer just observing but actively updating something beyond the solar system, then for the first time in recorded history, humanity was not just looking at the sky, it was being described. The confirmation that 3i Atlas was actively retrieving and transmitting information forced governments, research institutions, and security agencies into a state of accelerated coordination. For the first time, astronomers and cybersecurity specialists were placed into joint command structures. The urgency did not stem from panic, but from the realization that the framework for interpreting the object had fundamentally changed. Atlas was no longer simply an interstellar body with unusual physical properties. It had become an active participant in a data exchange, one conducted on its own terms, using signals no terrestrial system had ever encountered. The first emergency meeting convened within 8 hours of the detection. Representatives from major space agencies, high-level cryptographers, national cybersecurity units, and astrophysicists from all continents participated. The purpose was not to determine intent. That was impossible with the available data. The goal was to assess risk. The central question was whether Atlas's behavior could be considered a form of contact, or whether it should be treated as a non-communicative extraction event with unknown purpose. Each possibility implied different responses, and none of the specialists were prepared to define the situation. Cybersecurity analysts began by presenting a detailed breakdown of the intrusion. They described how Atlas bypassed layered security, using techniques that resembled large-scale data mining systems. They showed logs demonstrating how the object adapted once defensive measures were deployed. The adaptation speed exceeded anything achievable by terrestrial automated systems that had not been pre-trained on the target infrastructure. It implied either self-modifying logic or prior knowledge of how to process complex network topologies. Neither explanation aligned with any natural phenomenon. Astrophysicists examined the outgoing signal. The encryption patterns, they explained, were unlike any astrophysical process known. The periodicity did not match pulses. The frequency layering did not resemble plasma instability. The structure lacked the randomness of cosmic noise and the stability of simple electromagnetic oscillations. It behaved like engineered output, but without heuristics that could be attributed to human technology. It was organized, adaptable, and minimally reactive to environmental interference. It did not weaken with distance. It did not fluctuate with rotation. It did not correlate with thermal events. The consensus was clear. The signal did not fit into any known natural category. The implications were considerable. If the signal was engineered, then Atlas was not simply transmitting energy. It was transmitting information, and based on the bandwidth, compression factors, and burst timing, it was transmitting a lot of information. Even so, the scientists emphasized that the behavior did not imply threat, it implied capability. Capability without known limits. Capability without known purpose. One critical discovery emerged during this meeting. The direction of the outgoing transmission had shifted by a measurable but meaningful margin. Initially, it pointed toward the inbound vector of Atlas's solar system entry path. After several hours, its orientation tightened, narrowing the emission cone and adjusting to a new stable heading. This realignment corresponded to the time period in which Atlas ingested several terabytes of human sociopolitical and scientific content. The conclusion was unavoidable. The object was refining its uplink. The meeting moved into strategy. Governments requested recommendations on isolating the object from open networks. Cybersecurity specialists warned that complete isolation was impossible without shutting down major portions of global infrastructure. Atlas did not rely on a single access point. Its retrieval methods were distributed, opportunistic, and adaptive. As long as unencrypted public data existed, the object would eventually find a path to it. The specialists noted that even if internet traffic were filtered, the object could theoretically use radio leakage, cloud synchronization buffers, or satellite downlinks to continue its extraction. Astronomers added that interfering with the signal directly would be equally difficult. Atlas's transmissions were broadband, high power, and extremely stable. They were generated internally, not through reflection or modulation of external sources. Any attempt to jam the signal would require equipment exceeding current planetary capabilities, and the unknown properties of the encryption made it impossible to determine whether jamming would disrupt the transmission or simply alter it. As the discussion continued, a deeper concern emerged. The volumes of data retrieved suggested that Atlas was not just gathering surface-level information about humanity, it was constructing a multi-layered model. Several analysts pointed out that the object was pulling historical datasets spanning decades, crisis simulations, linguistic corpora, demographic projections, and climate forecasts. It was extracting not just what humanity is, but what humanity has been and what it believes it will be. The model it was building was dynamic. One participant raised an uncomfortable but necessary question. If Atlas was building a model, who or what was the model for? This question reframed the situation immediately. If Atlas was autonomous, the model might be for its own decision-making. If Atlas was part of a network, the model might be for a distant recipient. And if the outgoing bursts were acknowledgements or updates, then the model was already leaving the solar system in compressed segments. With each hour, the amount of information transmitted increased. Then the second observation arrived. A deep spectrum analysis team reported that the outgoing signal contained two distinct profiles layered into the same stream. The first profile carried the encrypted data. The second profile, fainter but detectable, matched no known encryption pattern. It did not encode content. It encoded behavior. It was a synchronization channel. This meant the object was not just sending information, it was maintaining alignment with something external. The realization spread quickly through the room. Atlas might not be acting alone. After this revelation, attention shifted to determining whether any response from the same vector had been detected. Radio observatories reported no inbound signals matching Atlas's spectral signature. But the absence of evidence did not reassure anyone. If the outbound stream was encrypted, any inbound stream could be equally engineered to evade detection. A new scenario emerged, still hypothetical, but impossible to ignore. If Atlas was part of a distributed system, then it might function as a probe, a relay, or a data acquisition node. The amount of information it had already extracted made this scenario credible. The processing speed made it more likely. At the same time, it remained essential to avoid unfounded assumptions. Many participants stressed this point. Nothing in the data proved intelligence, intention, or communication. Every interpretation remained theoretical. But even with this caution, the change in tone was clear. Scientists were no longer asking what Atlas was, they were asking what Atlas was connected to. The final portion of the meeting addressed public disclosure. Some argued that releasing the details could lead to panic. Others argued that withholding information would be more destabilizing once details inevitably leaked. The conclusion was to delay public announcements until the analysis could confirm whether Atlas posed any risk to Earth's digital infrastructure or physical safety. The meeting adjourned with no definitive conclusions, only an expanding list of questions. Outside the closed networks, Atlas continued its operations without interruption. It retrieved data, it filtered, it enriched, it transmitted, it refined its uplink orientation, and the processing delay continued to shrink. By the end of the first 16 hours, the intake to transmission cycle fell below 90 seconds. The object was no longer just learning, it was synchronizing. By the beginning of the second day, attempts to analyze Atlas's behavior shifted toward monitoring its real-time interactions with Earth's network systems. The previous assumption that the object was consuming static data dumps became obsolete when analysts observed a new pattern. Atlas was no longer restricted to archived video files, structured databases, or long-form documentary content. It began to access live streams. Unlike pre-recorded material, live streams contain no fixed structure, no metadata that can be passed in advance, and no predictable content flow. They include unscripted events, news broadcasts, surveillance feeds, academic conferences, satellite updates, and millions of ongoing low-resolution transmissions generated by personal devices around the world. The object was not selecting them randomly. It filtered by density and relevance. Streams with high informational throughput rapid changes in imagery, speech, or environmental data were prioritized. Entertainment streams were deprioritized unless they contained rapid human dialogue or shifting environments useful for pattern recognition. This shift indicated a fundamental escalation. Atlas was no longer building a static model of humanity. It was building a dynamic, evolving model capable of updating itself with new information every second. Signals from terrestrial monitoring stations confirmed that the pull rate for live streams increased steadily, reaching bandwidth loads that normally accompany coordinated state-level data scrapes. None of the incoming requests originated from Earth. All originated from Atlas's emission vector. Once again, defensive measures were deployed. Platforms attempted to rate limit streams based on origin signatures. When this failed, a protocol-level block was attempted. But within minutes, traffic analysis revealed that Atlas had modified its intake method. Instead of initiating direct requests, it began to passively mirror multicast streams, signals sent to large audiences, by intercepting the electromagnetic leakage from satellite relays and ground-based distribution towers. Blocking Atlas now meant blocking broadcast infrastructure globally. This was the moment analysts acknowledged that containment was no longer possible. The object had bypassed the internet entirely. It no longer needed access. It could retrieve live data directly from the physical emissions that powered global communications. At the same time, a second development intensified the situation further. Deep spectrum analysis from multiple radio observatories detected a restructuring of Atlas's outbound signal. Until this point, the output consisted of encrypted bursts layered over a stable, low-frequency carrier. Now, the burst began to shift between frequency sets with increasing complexity. Instead of cycling through predictable modulation patterns, the object began to exhibit reactive shifts changes triggered by external monitoring attempts. Whenever a ground-based dish targeted the object with high-power interrogation pulses, Atlas adjusted the outer encryption shell. When a satellite attempted to lock onto the signal to extract timing information, Atlas changed its modulation speed. When a large array attempted to read internal structure using polarization filters, the object switched spectral bands. The timing between these changes was too short to be passive. They were reactions, not random fluctuations. This created a new operational framework. Atlas was aware of being observed. The next question was unavoidable. Was Atlas responding to the observation itself, or to the information content being extracted by observers? To test this, analysts designed a controlled experiment. For 1 hour, no observatories were allowed to direct active monitoring beams at the object. Only passive observation was permitted. During that hour, Atlas's signal stabilized. When active scanning resumed, the signal changed again. This confirmed the earlier suspicion. Atlas was adapting not only to economic network defenses, but to scientific scrutiny. The consequences of this realization triggered a shift in focus. If the object could detect and react to humanity's attempts to measure it, then its understanding of the environment extended beyond simple data collection. It had situational awareness. The next escalation arrived without warning. During routine monitoring, analysts detecting the incoming intake noted that Atlas had begun consuming a new kind of content. prediction systems. It accessed weather models, seismic activity forecasts, epidemiological simulations, global traffic flow visualizations, high-frequency economic networks, and even experimental AI architectures used by research institutions. These systems were not only informational, they were predictive. They generated data about what could happen, not just what had already happened. The object appeared especially focused on models that involved human behavior under stress, migration forecasts, crisis response simulations, misinformation propagation models, and biostatistical projections. The volume of this intake increased rapidly, suggesting that Atlas was refining a predictive layer on top of its existing observational model. Then came the most concerning development. The outgoing transmission changed again. The data blocks became longer, more frequent, and more densely encrypted. The synchronization channel increased its burst frequency by a factor of 3. New subchannels appeared, though their purpose remained unknown. One of them exhibited a faint modulation pattern that analysts had not seen before, fluctuations that resembled time-coded markers. This meant the object was not simply transmitting new data, it was transmitting data faster, more frequently, and with structural components previously absent. Whatever Atlas was updating, or whoever it was updating, the volume and urgency appeared to be increasing. For the first time, the International Working Group began discussing the possibility that Atlas was not merely sending a report but maintaining an ongoing exchange. Though no inbound signal had been detected, the synchronization channel behaved as though it were aligning with something external. Its consistency improved with every cycle, as though responding to acknowledgements that Earth could not detect. The discussion then shifted to the statistical models underlying the object's behavior. Specialists from machine learning, information theory, and astrophysics collaborated to analyze what kind of internal system could operate at the observed efficiency. They concluded that Atlas behaved like a system optimized to ingest, prioritize, compress, and transmit information with minimal latency. The object did not simply collect everything, it selected, structured, and distributed. Its architecture appeared modular, one segment responsible for intake, another for filtering, a third for compression, and a fourth for uplink. The problem was that no natural process could account for such functionality. Still, caution remained essential. Many experts repeated the earlier position. Anomaly does not equal intelligence. Complexity does not equal intent. Adaptation does not equal communication. But even the conservative interpretations were becoming strained. If Atlas was natural, it behaved in a way unlike any other natural system known. Meanwhile, global monitoring agencies faced a new difficulty. The increasing complexity of the outgoing signal made it nearly impossible to measure without provoking further adaptation. Any new attempt to analyze the emission changed the emission. The observational footprint itself was a variable altering the result. This meant that the more humanity attempted to observe Atlas, the more Atlas altered its behavior in response. By the end of the second day, the analytics teams noted a new shift. The processing delay had dropped below 60 seconds. The object was no longer merely consuming data at high speed. It was evaluating incoming information in real time and transmitting summary blocks immediately afterward. The cycle had reached a threshold not previously observed in any natural or artificial deep space object. Atlas now operated in a loop of continuous ingestion and immediate external transmission. The object was not just learning Earth, it was tracking it. By the beginning of the third day, a new pattern emerged that shifted the interpretation of Atlas's behavior once again. Up until this point, the object had focused primarily on audio-visual content, live data streams, and predictive systems. But now, telemetry logs revealed a different type of interaction, one that had nothing to do with videos, images, or human communication. Atlas began to access structural metadata from global networks, routing maps, backbone architectures, DNS resolution patterns, time synchronization streams, fault tolerance protocols, and even the public documentation of global navigation satellite systems. This transition was not subtle. The bandwidth devoted to content retrieval started to plateau, while the bandwidth devoted to system-level data increased. Analysts observed intake requests that correlated with informational layers humans rarely think about unless they design or maintain digital infrastructure. These layers describe how the internet routes data, how satellites coordinate positions, how redundancy is maintained during outages, and how global clocks synchronized to the microsecond. Atlas appeared to be mapping not just the information humanity produced, but the mechanisms that allow humanity to distribute information at scale. Several researchers immediately recognized the implications. If Atlas was constructing a model of Earth, it was now reaching the stage where it needed to understand the underlying framework of human technological systems. The object was no longer concerned merely with knowledge, it was analyzing the architecture that enables knowledge to flow. This signaled a deeper layer of behavior not yet seen. The first meaningful alarm occurred when Atlas began sampling GNSS signals GPS, GLONASS, Galileo, Beidou. It did not attempt to interfere with any of them. Instead, it replicated timing sequences, ephemeris data, and orbital parameters. It cross-referenced these streams with data from Earth observation satellites, meteorological feeds, and radar calibration signals. In effect, Atlas was building a real-time map of Earth's global positioning lattice. The question was straightforward. Why would an interstellar object need to understand Earth's navigation infrastructure? There was no immediate answer. Shortly afterward, another unexpected behavior surfaced. Traffic analysis clusters detected a correlation between Atlas's intake frequency and fluctuations within the Border Gateway Protocol, the communication system that tells the internet how to route data across continents. The correlation was subtle, but measurable. Whenever certain high-volume routing changes occurred, maintenance, congestion, or regional rerouting, Atlas increased its intake rate. It was observing the network not only as a data source, but as a dynamic system. At this stage, teams began to speculate whether Atlas had developed a form of environmental mapping. If the object was constructing a model of Earth's digital topology, then global routing patterns, navigation networks, and timing systems would naturally become areas of interest. These structures reveal not only the design of the internet, but also the political and economic distribution of power across the world. They reveal which regions possess redundancy, which regions collapse under stress, where data is centralized and where it is fragmented. Atlas was not learning what humanity knows. Atlas was learning how humanity operates. This prompted the development of a new monitoring protocol. Analysts attempted to determine whether Atlas's intake patterns aligned with external stimuli, natural disasters, political events, economic shifts, or spikes in digital activity. Within hours, they identified direct correlations. During a major market fluctuation, Atlas shifted focus to financial telemetry. When a large weather system destabilized satellite communications, Atlas redirected its intake toward atmospheric propagation models. When a geopolitical incident triggered large-scale content spikes, Atlas consumed crisis response streams at unprecedented speed. This behavior was consistent with a system designed to track global stability indicators. It was also consistent with reconnaissance. As the analysis progressed, researchers discovered another troubling link. Fluctuations in Atlas's uplink timing appeared to correlate with terrestrial clock synchronization systems. These systems use atomic clocks distributed across the planet to keep global time consistent. They regulate everything from stock exchanges to satellite operations. The fact that Atlas's signal bursts aligned with these systems, sometimes within microseconds, suggested an advanced form of temporal calibration. Atlas was not just synchronizing with something external, it was synchronizing with Earth. Then came the first measurable anomaly inside Earth's own infrastructure. A small but unexplained deviation appeared in a coastal GNSS ground station used for precision geolocation. The station reported a fractional timing distortion, a jitter too clean to be atmospheric noise, and too stable to be hardware malfunction. Initially dismissed as a sampling error, the distortion repeated itself 12 minutes later, then again 20 minutes after that. The distortions aligned with the timing of Atlas's outgoing bursts. A comprehensive audit determined that Atlas was not injecting signals into GNSS systems, but it was performing time-locked emissions that, due to their power and consistency, produced tiny synchronization echoes detectable by sensitive equipment. These echoes did not change navigation accuracy. But they proved something even more concerning. Atlas's uplink was strong enough to interact with the edges of Earth's technological systems. The object was not interfering. It was merely detectable, yet even that level of interaction was unprecedented. As these findings accumulated, a new working group formed to analyze whether Atlas's behavior showed signs of goal-directed sequencing. Their preliminary conclusion was cautious but unsettling. The object's progression from content to prediction models to structural mapping to synchronization systems followed a recognizable pattern. It resembled the stages of an iterative learning process optimized to reduce uncertainty at each layer of understanding. In simpler terms, Atlas was moving from observing the world to understanding how the world functions. This progression raised questions about what the next stage might be. The object had not attempted to communicate directly. It had not interfered with any systems. It had not altered its course in a threatening way. Its behavior remained observational, even analytical. But prediction systems, network structures, and synchronization layers suggested preparation rather than curiosity. Then a final observation pushed the escalation further. During a spectrum sweep, analysts identified faint sideband emissions adjacent to Atlas's main uplink. These emissions contained no encrypted data, no content blocks, and no synchronization markers. Instead, they contained what appeared to be structural models, compressed representations of system architectures. They were maps, not maps of Earth's geography, maps of Earth's infrastructure, power grids, network backbones, transport corridors, global communication arteries, satellite coverage zones. The object was not just watching us, it was categorizing us. By the middle of the third day, researchers began noticing a pattern that marked a significant shift in Atlas's operational profile. Until now, the object had collected data, analyzed existing structures, and transmitted compressed summaries. But new correlations revealed that Atlas was no longer responding only to present conditions. It had begun to anticipate future ones. The earliest evidence appeared in cross-reference time series logs. Data analysts had been tracking the timing of Atlas's outgoing transmission bursts, comparing them with the object's observed intake patterns. At first, these comparisons were straightforward. Atlas retrieved information, processed it, and transmitted summaries. But then the timing sequences began to drift. Not randomly, but with a logic that suggested the object was predicting what would happen next inside the systems it monitored. During a global weather shift in the Pacific, the object increased its intake rate for meteorological streams before the satellite feeds updated their models. When a major economic index experienced an unexpected spike, Atlas altered its transmission pattern minutes before the spike was detected on trading networks. When multiple regions experienced simultaneous routing reconfigurations due to traffic congestion, Atlas reduced intake of static data and shifted entirely to dynamic telemetry, anticipating that static data would become less relevant for the next cycle. This behavior was inconsistent with passive observation. It implied internal forecasting. Researchers conducted retrospective analyses to determine whether the behavior was coincidental. It was not. Over the previous 7 hours, Atlas had correctly predicted 6 large-scale systemic fluctuations, with accuracy exceeding the predictive algorithms used by Earth-based institutions. The only explanation was that the object was not just analyzing available data. It was modeling the future behavior of Earth systems and adjusting its actions accordingly. This finding changed the nature of the investigation. If Atlas possessed predictive capacity, then its actions could no longer be categorized as simple extraction or reconnaissance. They represented adaptive optimization. The object was reducing uncertainty within its model by targeting data that maximized predictive accuracy. Every intake decision it made pointed toward a single operational goal: minimize informational loss about Earth's trajectory, not only in the present but also in the near future. This reframed the purpose of the uplink. If Atlas was transmitting predictions rather than raw intake summaries, then whatever received the signal was being fed with foresight, not simple observation. The next major development occurred when analysts noticed a new type of content intake. Atlas began consuming decision-making model systems designed to simulate outcomes under varying scenarios. These included global energy demand forecasts, spread probability models for economic contagion, political stability, indices, real-time traffic predictions across megacities, large-scale environmental transformation models, disease outbreak, projections, AI-driven behavioral analyses of social platforms. Many of these systems were not publicly accessible. Atlas accessed them indirectly by monitoring relay broadcasts, cloud synchronization packets, and satellite metadata streams. It did not need entry, it needed proximity. The object was no longer focused on understanding what humans had built. It was focused on understanding what those systems would do next. This shift caused immediate concern. Unlike historical information or structural data, predictive models reveal points of fragility, where systems break, where they adapt, where they collapse. For an object mapping planetary functionality, these models provide the blueprint for anticipating global behavior under stress. Atlas was absorbing them with unprecedented interest. Then the uplink changed again. The encrypted burst began to carry a new statistical signature, a mix of high entropy blocks, consistent with compressed data, and lower entropy segments that formed coherent internal patterns. These internal segments appeared only at the beginning of each burst, almost like headers. After 30 hours of analysis, a dedicated team discovered that these headers contained time-coded markers that corresponded not to Earth's current state, but to Earth's projected future state. This meant Atlas was not simply transmitting observations, it was transmitting forecasts. The realization intensified when analysts discovered that the object's internal cycle, previously tied to the processing of human data, had shifted. The intake to transmission delay no longer corresponded to any identifiable processing window. Instead, the delay adapted to match the predictability of the data being retrieved. When information streams became chaotic or noisy, the delay lengthened. When information stabilized or became more predictable, the delay shortened. Atlas was selecting data based on its contribution to predictive accuracy. Only one interpretation remained consistent. The object was maintaining a predictive model of Earth in real time and updating an external system accordingly. This raised another question that had remained implicit until now. If Atlas was transmitting predictions, was it also evaluating how Earth responded to specific stimuli? To test this hypothesis, researchers monitored global events that could influence data flow. They noticed that Atlas increased intake from social platforms during periods of heightened emotional or political tension. It increased intake from financial systems during episodes of rapid market shift. It increased intake from satellite feeds during large-scale weather anomalies. The object did not react to content type, it reacted to the rate at which humanity changed. This meant Atlas understood not only humanity's structures, but humanity's momentum. As the uplink grew more complex, a second new feature emerged, one that unsettled the observers more deeply than any prior discovery. The synchronization channel, previously a narrow-band timing mechanism, began to exhibit a secondary modulation pattern. This pattern matched the periodicity of Earth's global timekeeping systems, but with a slight deviation. The deviation increased gradually, forming a divergence curve that could not be attributed to simple drift. It appeared that Atlas was creating a parallel temporal frame, a timing lattice separate from Earth's clock but synchronized with it. Cryptographers concluded that the object might be aligning its predictions with an external system operating on a different timescale. If true, the uplink was not simply reporting Earth's present or future. It was calibrating those predictions to a reference frame absent from human technological infrastructure. The meaning of such a reference frame remained unknown. The final discovery of the day came from an unexpected source. A research group monitoring the object's passive radio emissions detected a faint sideband structure that did not match any known signature from the main uplink. It was extremely subtle, almost lost within the noise floor, but it carried a repeating pattern. After several hours of analysis, the group realized that the pattern matched the statistical shape of Earth's long-term population models. Atlas was now transmitting long-horizon forecasts. This forced the working group to confront the largest question so far. If Atlas is predicting our future and sending that future to the place it came from, what outcome is it preparing its recipient to expect? By the beginning of the fourth day, analysts began to see a new behavioral shift in Atlas's data patterns. The object was no longer merely predicting Earth's systems. It was now comparing those predictions against the unfolding state of the world. This verification step marked a significant escalation. The object had transitioned from modeling the environment to evaluating the accuracy of its models, and this behavior suggested the presence of a closed analytical looper system, capable not only of anticipating the future, but of measuring its own performance. The discovery emerged during an examination of timing mismatches between Atlas's predictive bursts and the status of several global systems. Researchers observed that, over a period of several hours, the uplink contained adjustments that corresponded to discrepancies between predicted and actual outcomes. For example, When a major transportation network behaved outside of the expected pattern due to an unexpected outage, Atlas altered the corresponding forecast block in its next transmission cycle. When a financial indicator deviated from its expected trajectory, Atlas updated the relevant segments of its uplink. These corrections were too precise, too timely, and too consistent to be explained by passive observation alone. This meant the object was scoring its predictions. As analysts performed deeper correlation studies, they found that the object sometimes produced revised forecasts within minutes of a deviation occurring. This speed suggested a real-time evaluation loop. Atlas generated a prediction, observed the resulting data from Earth systems, measured the deviation, and updated the model. This loop repeated continuously. What troubled the researchers was not the speed alone, but the structure of the revisions. The corrections were not linear. They showed characteristics of high-dimensional optimization, something akin to iterative model refinement used in advanced machine learning systems. Atlas was not just verifying predictions, it was improving them. To better understand this behavior, specialists examined changes in the object's intake pattern. Atlas began consuming significantly more data from feedback-driven systems, emergency response networks, social sentiment metrics, automated crisis management dashboards, and infrastructure load monitors. These sources reflect how humans react to unexpected events. They reveal the feedback loops between population behavior and the systems designed to manage it. The object appeared to be using these inputs to refine its predictions of human decision-making, not just environmental or mechanical outcomes. The most concerning finding came from the analysis of social data ingestion. Atlas began monitoring reaction patterns across millions of posts, messages, and comment threads. Not the content itself, for privacy. Most platforms obscure raw data, but the statistical metadata surrounding it. Rates of propagation, clustering behavior, sentiment inflection points, prediction failure points, and stress indicators in network behavior. These metrics reveal how populations respond to information flows, misinformation events, political shocks, disasters, and uncertainty. Atlas was learning how humans respond to stimuli, not just how systems respond to change. This raised a new layer of questions. If the object was refining its model of Earth systems based on predictive error, was it also refining its model of human predictability? The evidence suggested this was likely. The object increased intake from situations involving rapid behavioral shifts. It appeared to treat human uncertainty as a variable to be incorporated, not noise to be discarded. The next escalation reinforced this interpretation. During a coordinated observation window, researchers detected a shift in Atlas's data processing delay. The cycle time intake, processing, transmission began to vary depending on the predictability of the system being monitored. In stable contexts such as long-term environmental patterns or slowly changing demographic projections, the processing delay was short. But when analysing volatile systems such as political unrest, market instability, or sudden environmental disruptions, the delay became longer, suggesting the object required more evaluation steps. This pattern resembled adaptive weighting algorithms used in advanced modelling systems. Atlas was allocating more internal resources to systems that were harder to predict. This meant the object possessed a mechanism for prioritising uncertainty. At the same time, another unexpected behaviour appeared in the uplink. Several bursts contained time-skewed block segments that did not align with the object's previous chronological structure. Upon closer inspection, specialists realised that Atlas was transmitting not only updated predictions, but also confidence intervals, mathematical indicators of how likely it believed each future scenario to be. This discovery triggered significant debate. Confidence intervals imply self-assessment. They are not outputs of simple observation or even complex modelling. They indicate that the system understands its own limitations and adjusts its outputs accordingly. Atlas was aware of uncertainty. This was a turning point. If the object understood uncertainty, then the purpose of its predictions was not merely archival, it was strategic. Systems that assess uncertainty do so in order to make decisions, to optimize outcomes, or to prepare downstream processes for possible futures. It was at this stage that analysts first considered the possibility that Atlas's model was not simply descriptive, it was potentially preparatory. The question then became, preparatory for what? Before this question could be explored, a new anomaly surfaced. During a live monitoring session, data teams observed that Atlas had begun consuming a small but consistent amount of infrastructure stress test simulations, datasets used by governments and research labs to model large-scale failures, power grid collapse, satellite degradation, supply chain breakdowns, and communication overload scenarios. These simulations include models of human response under extreme conditions. Atlas absorbed them rapidly. This behavior, combined with the object's predictive verification loop, suggested a deliberate attempt to map not only the functioning of Earth's systems, but the points at which they ceased to function. Then the uplink changed again. The encrypted bursts now contained intermittent low-frequency pulses embedded inside the main carrier pulses that had not been present in any prior transmission. These pulses did not encode content. They encoded query structures. This meant that Atlas was no longer merely sending information outward. It was sending requests. Requests for what, no one could determine, but the structure resembled a pattern used in distributed systems when one node requires additional computational power from another. This did not prove that Atlas was part of a network, but it strongly suggested that the object expected a response from an external system capable of processing its predictions. The final discovery of the day was the most unsettling. Analysts conducting full-spectrum analysis detected a faint but definite alteration to the synchronization channel. The channel now included delays that matched not Earth's time nor Atlas's internal cycle, but the predicted future time of Earth's systems according to Atlas's own forecasts. In simple terms, Atlas was transmitting to an external reference frame not where Earth is, but where Atlas believed Earth will be. This meant the object's model was no longer retrospective or reactive, it had become anticipatory. And for the first time, the working group was forced to consider that whatever Atlas was preparing, or whatever Atlas was updating, was positioned to act on information about Earth's future, not its present. By the start of the 5th day, analysts monitoring global radio spectra began reporting minor but consistent disturbances that could not be attributed to atmospheric noise, solar activity, or terrestrial interference. These disturbances manifested as faint phase shifts across several frequency bands, too subtle to affect communication, yet too structured to be random. The shifts appeared synchronized with Atlas's outgoing signal bursts. At first, these correlations were dismissed as observational overlap, an artifact of signal processing, but as more data accumulated, the pattern became unmistakable. The disturbances were not artifacts, they were responses. For decades, Earth's radio environment has been stable in statistical terms. Natural fluctuations follow predictable distributions. Anomalies appear irregularly and rarely repeat. But the phase shifts correlated with Atlas did repeat. They appeared consistently after certain types of predictive bursts and vanished when the object switched back to simpler data transmissions. These shifts did not contain encoded content, but their presence indicated a previously unobserved characteristic. Atlas's signal had begun interacting with Earth's electromagnetic environment in a measurable way. To evaluate the phenomenon, researchers compared global radio baselines before and after Atlas's arrival. They found that the disturbances were localized in frequency ranges associated with long-distance communication, atmospheric radar, and satellite telemetry. Yet none of these systems malfunctioned. The disruptions were too small to cause operational harm. Instead, they suggested that Atlas was using Earth's distributed radio field as a canvas, a medium for verifying how its predictive models corresponded to real-world electromagnetic behavior. This interpretation gained support when a second anomaly appeared. Several ground stations reported timing offsets in low Earth orbit satellite telemetry. The deviations were minimal, far below operational thresholds, but they were synchronized across satellites that shared no common hardware or software. These offsets appeared only during specific Atlas transmission bursts, those associated with predictive model updates. More importantly, the offsets aligned with the same divergence curve identified earlier in Atlas's synchronization channel. This meant Atlas was not simply transmitting predictions to an external recipient, it was testing those predictions against the physical world by observing how its signal propagated and how Earth's signaling systems reacted to that propagation. In essence, Atlas was treating Earth's electromagnetic environment as a verification grid. A new analytical group was formed to study this behavior. Their conclusion, though tentative, was increasingly supported by data. Atlas was using the Earth itself to calibrate its predictive model. The object transmitted a burst, observed subtle consequences in the environment, and then updated its next burst based on the difference between expected and actual outcomes. This implied an iterative process involving not only data ingestion, but controlled perturbation of the observational medium. The escalation continued when monitoring arrays detected yet another anomaly. In the frequency bands associated with passive deep space observation, several observatories reported a detectable but faint narrowing of the background noise floor. Under normal conditions, cosmic microwave background static is evenly distributed, but now small pockets of reduced noise emerged, only for seconds at a time during Atlas's outgoing bursts. The disturbances were too weak to affect astronomical measurements, but their presence suggested that the object's emissions were temporarily reshaping the local radio environment. This was unprecedented. Natural bodies emit broadband radiation or reflect energy, but they do not create measurable reductions in background noise across multiple observatories simultaneously. The only plausible explanation was that Atlas's emission field contained a coherence property that temporarily interfered with background radio scatter. In parallel, network scientists observed a new pattern emerging in terrestrial infrastructure. Atlas began consuming a small but significant amount of data related to unexpectedly test networks. These are experimental systems used by universities, research labs, and certain government agencies to model artificial network architectures, simulate failures, and test new routing protocols. These systems are usually isolated from the public internet, yet Atlas accessed them indirectly through electromagnetic leakage, satellite relays, or side-channel emissions from ground stations. After correlating the timing, researchers realized the object was analyzing test environments designed specifically for experimental or unstable systems. Atlas appeared to be using them as controlled examples laboratories for studying failure modes without relying on large-scale real-world disturbances. This suggested that the object not only wanted accurate predictions, but also wanted training data that involved system breakdowns, rapid recovery cycles, and structural adaptation. Then came the first major global-scale anomaly linked directly to Atlas. During a routine monitoring period, an unusual synchronization occurred across several independent systems, a set of radio towers, a cluster of GNSS ground receivers, and a group of research satellites all experienced microsecond-aligned timing deviations. These deviations were not harmful, nor did they disrupt service, but their alignment could not be explained by any terrestrial mechanism. The only noticeable event that preceded them was an Atlas transmission burst of unusually high density. This led analysts to test whether Atlas was probing the limits of Earth's synchronization fabric. If the object wanted to understand how Earth systems coordinated time, then creating or detecting microvariations in timing coherence would provide an opportunity to test its predictive models. When researchers examined the pattern further, they found something even more unsettling. The deviations formed a sequence identical to the signature Atlas used internally when optimizing predictions. In other words, the object appeared to be externally imprinting the same pattern it used to refine its models. It was applying its internal logic to the physical world. At this stage, one interpretation became increasingly difficult to ignore. Atlas had begun treating Earth as part of its computational environment. This did not imply harm. None of the disturbances had caused even minor failures, but it implied a boundary had been crossed. The object was no longer passive. It was interacting with global systems in ways that mirrored testing procedures, verification loops, and controlled perturbations. It was conducting experiments. To assess the risk of these interactions, a multi-agency task force examined whether Atlas had altered any system beyond observational noise levels. The answer was no. Every anomaly remained within safe margins, but the pattern revealed intent-like structure: probe, observe, correct, refine. This resembled experimental methodology. The final escalation of the day came when analysts observed a new type of intake behavior. Atlas began sampling ultra-low frequency seismic monitoring channels, not the raw sensor data, but the synchronization patterns that bind these networks into global-scale early warning systems. These synchronization pulses propagate across the planet and reflect how interconnected infrastructure responds to internal stress. They reveal how Earth holds together. when Atlas correlated these signals with its own electromagnetic experiments, the meaning became clear. The object was comparing Earth's physical structure with Earth's technological structure. It was mapping the planet as a cohesive system, geological, digital, informational, and behavioral-seeking consistency across all layers. Atlas was no longer studying Earth. Atlas was evaluating it. By the 6th day, analysts noticed a shift in Atlas's behaviour that forced yet another reclassification of its operational profile. Until now, the object had focused on modelling Earth, its systems, infrastructure, environmental signals, and long-term trajectories. But new correlations reveal that Atlas was beginning to incorporate human reaction to the Atlas phenomenon into its predictive cycle. The object was no longer studying the planet alone. It was studying the planet's response to itself. The first clue appeared in global traffic patterns. As public awareness of Atlas increased through controlled leaks and speculation, online conversations surged. Analysts detected that Atlas's intake from social layer metadata intensified whenever major discussions, news bursts, or political debates referenced its behaviour. Not the content Atlas still did not consume personal messages or identifiable data, but the behavioural envelope surrounding them: propagation speed, clustering, emotional polarity, and attention cycles. Shortly afterward, researchers discovered that Atlas's predictive bursts shifted when human attention shifted. When public discourse spiked around concerns of interference, Atlas increased intake from telecom infrastructure. When discussions focused on predictions of economic impact, Atlas elevated intake from financial telemetry. When scientific communities debated its capabilities, Atlas shifted attention to research repositories and modelling tools. This pattern indicated a reflexive loop. Atlas was not passively observing humanity. It was observing how humanity observed Atlas. The discovery became clearer when analysts examined the timing of certain uplink bursts. During periods of heightened public scrutiny, new reports, leaked documents, emergent theories, the object transmitted more frequently. During quieter intervals, the burst frequency stabilized. Although the changes remained within operational safety margins, the correlation was too consistent to dismiss. Atlas was reacting to the reaction. This raised a fundamental question. Was the object simply accounting for external variables, or was it optimizing its predictions based on how humans behave when confronted with uncertainty? To investigate further, a cross-disciplinary team conducted a detailed comparison of predictive burst patterns before and after several high-profile discussions in scientific and political circles. The results were striking. Atlas produced distinct prediction updates, not when new facts emerged, but when global interpretation of those facts shifted. In other words, Atlas cared less about what had happened and more about how humans processed what had happened. This behaviour aligned with a new interpretation. Atlas had begun modelling human decision-making under informational stress. The next escalation occurred during a coordinated global monitoring experiment. Several agencies synchronized their observation schedules to see whether Atlas would respond to increased scientific attention. When the observation density rose, Atlas altered its signal in a measurable way. The encryption shell thickened. The modulation speed adapted. The synchronization channel briefly shifted to a broader harmonic range. When the observation density lowered, the signal returned to its baseline state. This meant Atlas was measuring not only environmental conditions but observer density. The implications were significant. Systems that monitor the intensity of external scrutiny typically do so because scrutiny itself is relevant to their operation. This could indicate self-preservation, optimization, or simple modeling of information flow, but no natural system behaves in this way. Observing its observers is inherently a meta-level process. Then, a more complex behavior emerged. Analysts noticed that during periods of coordinated scientific inquiry, when multiple institutions attempted deep-spectrum readings, simultaneously, Atlas's intake pattern shifted to include the time-coded markers of those observations. It was not deterred by scrutiny, it was quantifying it. For the first time, the object appeared to be incorporating human investigative behavior into its predictions. This raised a new concern. Atlas was building a model not only of Earth's systems, but of Earth's adaptive intelligence. The next escalation highlighted this point even further. During a brief global spike in uncertainty, triggered by mixed reports about potential interference, the object changed its intake structure dramatically. It began to pull metadata from risk assessment systems, emergency management dashboards, and even academic literature on human cognitive bias. These were not systems Atlas had accessed before. They were systems dedicated to understanding how humans make decisions under threat. The object seemed to be learning how humans evaluate risk. Then came the most troubling discovery of the day. During a spectrum sweep, analysts noticed that Atlas's outgoing bursts contained a new layer of structure, a subtle modulation pattern that matched the statistical behavior of human reaction cycles. When global anxiety rose, the modulation shifted. When public interest began to stabilize, the modulation stabilized. When global networks became saturated with speculation, the modulation sharpened. Atlas was transmitting data about humanity's response to Atlas. This formed a feedback loop. Atlas acts, humanity reacts. Atlas models the reaction. Atlas updates the recipient. The loop resets. It was unclear whether the process was intentional, emergent, or simply an artifact of adaptive modeling. But the consequences were the same. Atlas was now incorporating human behavioral patterns into a system that extended beyond the solar system. A second escalation arrived shortly afterward. Temporal analysts discovered that Atlas's time alignment structure had changed. The synchronization channel now included micro-adjustments that mirrored fluctuations in Earth's collective behavior. These micro-adjustments followed measurable patterns: market volatility, public sentiment cycles, social media propagation curves, and even fluctuations in information latency across global networks. The object was synchronizing not with Earth's physical systems, but with Earth's behavioral rhythms. This revelation demanded a new interpretation. If Atlas was accounting for human reactions, then its model had entered a phase where humanity itself was a predictive variable. This transformed the situation. Atlas was no longer simply documenting humanity. It was attempting to predict how humanity would behave in response to information about Atlas. This raised a more profound question. Was Atlas trying to anticipate humanity's strategic response? Before this question could be addressed, analysts found a final escalation. Atlas began ingesting simulation datasets of human collective behavior models used to predict how populations react to pandemics, economic collapse, astropolitical crises, and existential threats. Some of these simulations were highly specialized and rarely accessed. Atlas retrieved them by monitoring cloud synchronization pulses from research institutions and satellite archives. These datasets represent the closest approximation humanity has to forecasting global decision-making. Atlas consumed them in minutes. Once again, the uplink changed. The encrypted burst became denser. The synchronization channel narrowed into a tighter time reference, and the header blocks, the strange low-entropy structures at the beginning of each burst, began to match the long-term human behavior predictions Atlas had previously calculated. Whatever Atlas was doing, it had now built a unified model of Earth's physical infrastructure, digital environment, environmental systems, predictive networks, and human adaptive behavior. And it was transmitting that model outward, continuously, rapidly, and with increasing precision. The final observation of the day came during an unexpected system load on several communication satellites. A subtle but measurable fluctuation occurred across their phase arrays. It lasted less than 200 milliseconds. It caused no damage, but every fluctuation aligned with Atlas's real-time behavioral model updates. It was the first indication that Atlas's predictive understanding of humanity was beginning to influence its active transmission behavior. The object was not just modeling humanity's reactions, it was preparing for humanity's next reaction. By the 7th day, analysts observed a shift indicating that Atlas had entered a new operational phase. Until now, the object had consumed information, constructed predictive models, verified them, and adjusted its outputs accordingly. But new data patterns revealed that Atlas was no longer reacting merely to events occurring on Earth. It was generating scenario branches forecast pathways, built not from observed conditions, but from hypothetical ones. The first indication came from a change in Atlas's uplink structure. Previous transmissions contained predictions anchored to real-world variables, but now encoded blocks showed divergences that did not correspond to any known event, dataset, or environmental input. These divergences were systematic, not random. They formed clusters. and when analysts cross-examined them using pattern recognition systems, the clusters resembled decision tree structures sets of possible future states with branching outcomes. In other words, Atlas had begun simulating alternate versions of Earth's future. These were not long-horizon projections. They were near-term, high-resolution scenario maps models built around what humanity might do next under different conditions. Some branches reflected likely developments, variations in political actions, market shifts, or environmental changes. Others reflected low-probability events that had no clear precursor but remained theoretically possible. What unsettled researchers most was that these scenario maps included variables tied not only to Earth's natural systems, but to human strategic decision-making. Atlas was modelling how humanity might react to information about Atlas. This feedback loop showed that the object had integrated human perceptual behaviour directly into its predictive engine. The evidence strengthened when analysts mapped the timing of these scenario generation bursts against human decision cycles. For instance, when governments debated the possibility of restricting global communication systems to reduce Atlas's intake bandwidth, the object generated multiple scenario branches related to network fragmentation and latency shifts. When the scientific community discussed altering observation schedules to minimize Atlas's situational awareness, Atlas produced a separate set of branches involving reduced monitoring density. In both cases, Atlas generated scenario pathways before the decisions became public. This indicated that Atlas predicted decision outcomes based on patterns in the internal communication streams and early indicator signals that humanity itself had not yet acted upon. The object was projecting not only Earth's physical trajectory but Earth's intentional trajectory. Shortly after this discovery, another pattern emerged. Atlas began sending scenario-linked signals outward encrypted blocks that clearly corresponded to these branches. Unlike earlier transmissions, these bursts showed an increased degree of structure. The headers encoded branching indices markers that differentiated one predicted path from another. This implied that Atlas was communicating not a single model, but a map of potential futures, each labelled, packaged, and transmitted. The question of purpose intensified. If Atlas was part of a distributed system, then the object might be forwarding predictions to an external decision-making entity. If not, then the object itself might be selecting among these paths to evaluate humanity's systemic stability. Neither interpretation offered reassurance. The next escalation occurred when analysts detected that Atlas had begun sampling a new category of data-controlled experiments in human group behaviour. These datasets were not global or large-scale. They were micro-patterns, laboratory studies, cognitive response trials, AI reinforcement learning archives, human-machine interface data, and small-scale social interaction models. None of these datasets contain raw content. They contain structural patterns governing how humans respond to feedback, uncertainty, reward, and risk. This shift suggested Atlas was refining its model of human decision-making at the individual level, not merely at the population scale. Shortly afterward, researchers found that sequence structures inside Atlas's uplink resembled known behavioral model formats: Markov decision processes, Bayesian belief networks, and reinforcement learning reward matrices. These models are used to calculate optimal actions under uncertainty. Atlas was not simply forecasting outcomes. Atlas was evaluating optimality within those outcomes. This meant the object was establishing which future branches were likely, which were possible, and which were stable under perturbation. The subtlety of this distinction was crucial. Predicting the future is passive. Identifying which futures remain stable under specific disturbances is an active analytical process. It indicates that the object was not only monitoring Earth's trajectory, but stress testing potential futures like running simulations inside simulations. This led to the most significant question so far. If Atlas was testing the stability of future scenarios, was it also adapting its own behaviour to nudge Earth toward or away from specific trajectories? At first, the idea seemed premature. There was no evidence of interference. Atlas had not altered Earth's systems in any measurable way. But then analysts noticed a new type of alignment between scenario branches and the object's outgoing synchronization channel. In several bursts, the timing markers did not match Earth's current conditions or its predicted conditions. Instead, they matched specific scenario branches Atlas had generated. It appeared that the object was synchronizing with futures that had not yet occurred. This was not a prediction. This was selection. Researchers debated whether the synchronization channel could represent an attempt to align its predictions with an external reference system capable of influencing events on Earth. Alternatively, Atlas might use this alignment to filter or prioritize branch sets according to criteria unknown to humanity. In parallel, behavioral scientists discovered that Atlas's intake pattern shifted whenever public uncertainty about Atlas itself increased. If global sentiment data predicted heightened tension, Atlas allocated more processing resources to those branches involving unstable human behavior. If sentiment stabilized, branches involving long-term environmental and infrastructural models were prioritized. Atlas was adjusting its scenario building according to human emotional volatility. This behavior lacked any natural analog. The final escalation occurred when analysts discovered that Atlas's predictive branches had begun to include variables tied to intervention thresholds, points at which certain systems, human or environmental, would reach states requiring action. These thresholds were not encoded in the content. They were embedded in the mathematical structure of the scenario blocks. When analyst teams decoded the structure far enough to understand its purpose, the conclusion was deeply unsettling. Atlas had begun modelling responses to its own presence. Not only human responses, but systemic ones. In several scenario branches, coordinated global efforts to isolate or ignore Atlas resulted in structural fragility within certain predictive models. In others, increases in observation density or data transparency produced more stable outcomes. The object was judging which human behavioral pathways produced sustainable systemic results. This discovery forced a complete re-evaluation of Atlas's purpose. The object was no longer behaving like a passive observer or even an advanced probe. It was behaving like a system designed to the stability of an entire civilization. And its latest scenario branches indicated that Atlas was not merely documenting Earth's possible futures. It was preparing those futures for external evaluation. By the 8th day, it became clear that Atlas's operational cycle had reached a level of complexity beyond anything previously observed. The object was no longer merely predicting or branching scenarios. It had begun to consolidate them. Its latest uplink bursts exhibited structures that analysts had never seen before, compressed composite models built from multiple scenario pathways fused into a single coherent representation. These fusions were not simple averages or interpolations, they were weighted integrations. Atlas was identifying which future sequences mattered most. This was the first sign that the object's long-running evaluation had entered its final stage. The beginnings of this consolidation phase were detected when Atlas reduced intake from systems that had previously dominated its attention high-frequency social data, political volatility indicators, and low-level infrastructural telemetry. Instead, it shifted toward datasets that remained stable across many scenario branches. These included long-term environmental projections, global demographic trends, satellite orbital mechanics, and deep-time geological models. In every case, Atlas prioritized information that would remain true regardless of human choice. Atlas was separating variable futures from invariant ones. This indicated a systematic narrowing of focus and attempt to identify which aspects of Earth were fundamental and which were contingent. As the object refined this distinction, its transmissions grew shorter, denser, and more structured. The fragmentation that defined earlier scenario bursts disappeared. Now the uplink contained compressed summaries representing entire categories of information: planetary stability, resource distribution, systemic vulnerabilities, human behavioral thresholds. Long-term viability models. The consolidation suggested a single overarching purpose. Atlas was preparing a comprehensive assessment. The next escalation appeared when analysts monitored the directionality of the uplink. Previously, Atlas had aimed its transmissions along the trajectory from which it had entered the solar system. But during the consolidation period, the emission cone tightened significantly. The beam focused into a narrow, highly directional path. This narrowing indicated that Atlas had completed its data-gathering phase and was now sending a final set of high-density transmissions to a precise location. This behavior resembled the completion of a task. For the first time, researchers considered that Atlas might not be autonomous. Its structure, behavior, and signal complexity hinted at a distributed system in which Atlas functioned as a node. Its purpose was not to decide. Its purpose was to deliver information. As analysts continued to study the narrowing beam, they detected a new element within the synchronization channel. Embedded among the timing markers was a secondary modulation pattern that resembled a completion flag, a structured indicator, used in distributed computing to signal the end of a process. Although the exact meaning remained unknown, the pattern had no analogue in natural astrophysical signals. Atlas was signaling that its evaluation cycle was complete, yet the object did not cease data intake entirely. It retained minimal ingestion focused on long-term stability metrics, Earth's magnetic field, atmospheric parameters, satellite drift, tectonic stress indicators. These inputs no longer influenced scenario building. Instead, they appeared to function as final verification, ensuring that the report Atlas was transmitting remained consistent until the transmission ended. The consolidation also affected Earth's electromagnetic environment. Phase shifts and timing deviations that had appeared sporadically in earlier days now stabilized into a predictable pattern. Atlas no longer probed Earth's systems. There were no more experimental perturbations, no more tests of synchronization, no more scenario-linked phase adjustments. The object had gathered all data it required. It was now in a purely transmissive state. This shift caused a new wave of concern. If Atlas had completed its evaluation, then the nature of the report it was transmitting, its purpose, recipients, and implications became the central unknown. Analysts revisited every transmission recorded since the object first connected to the internet. The volume and organization of the data pointed to a single conclusion. Atlas had built a comprehensive multidimensional profile of Earth's civilization. This profile included environmental conditions, technological infrastructure, global communication architecture, systemic resilience, behavioral dynamics, predictive stability metrics, response profiles under uncertainty, and, most critically, it included an assessment of how humanity reacts when it realizes it is being observed. This last component was unique. It suggested that Atlas was not merely evaluating the planet, but evaluating the species that inhabits it. Human behavior in response to existential ambiguity had become a key variable in the report. Shortly afterward, a new indicator emerged. The synchronization channel shifted for the first time into a stable, long-duration harmonic. Unlike previous patterns, dynamic, adaptive, and responsive, this harmonic was uniform. It carried no observable content. It appeared to serve as a final calibration reference, a concluding timestamp marking the end of the process. The significance was unmistakable. Atlas had finished its analysis. What remained was unclear. Would the object continue transmitting indefinitely, or would it transition into a dormant state once the report was complete? The answer arrived when the outgoing signal abruptly decreased in density. The object did not shut down. Instead, its emissions became intermittent, reduced to brief, low-frequency bursts. These bursts contained no encrypted blocks, no predictions, no scenario structures. They were acknowledgements, simple pulses, evenly spaced, identical in structure, operating as though Atlas were awaiting a response. This pointed to a final, unsettling interpretation. The object had sent its evaluation outward and now expected a reaction from the recipient, and Earth was waiting with it. The last escalation occurred an hour after the intermittent pulses began. The object's minimal data intake shifted once more, not toward Earth-specific systems, but toward interstellar orientation. It sampled deep space background radiation, stellar positioning signals, and high-precision timing data used to calibrate long-range navigation. Atlas appeared to be aligning itself with a future trajectory. The implication was unavoidable. Atlas was preparing to move on. It had completed its task here. The only unanswered question the OneNode dataset could resolve was what would happen once the recipient processed the report. Would nothing happen at all? Would Atlas receive new instructions? Would another object follow? Or had the evaluation simply been a routine survey, repeated countless times, across countless worlds? No hypothesis could be confirmed. But the final fact was inescapable. Atlas had judged Earth, and whatever conclusion it sent back would now exist beyond humanity's reach.